So these are the instructions from your book for how to determine or predict molecular geometries. Draw the Lewis structure, determine the total number of electron groups, determine the number of bonding groups, and the number of lone pairs. I'm all good with that. Number 4. Seriously? Refer to table 10.1. No. Because I'm not going to give you table 10.1 on an exam. So how's that going to help? Think about how balloons would arrange themselves. Your number of electron groups is the number of balloons. Remember this thing that I made with the balloons. Then imagine that any of the lone pairs are invisible balloons, and the molecular geometry is describing the ones that you can see. So let's practice. Predict the molecular geometry and bond angle of ClNO. We have to start with the Lewis structure. ClNO, there's 3 atoms there, and so we could be a little confused about what goes in the middle. Generally, if we're giving you something like that, try the simplest thing first. There's probably a reason that it's given in that order, and it is because we want you to put nitrogen in the middle. So you've got chlorine and nitrogen and oxygen. Now we can't just say, oh, well, that's going to be linear, because there might be some lone pairs involved. So we have to do the full Lewis structure. There's 7 valence electrons from the chlorine and 5 from the oxygen and 5 from the nitrogen, 6 from the oxygen. So that's what, 18? And I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, just sort of randomly. So I need to make a double bond. And we can get this right without actually going into formal charges. How many bonds does oxygen like to have? 2. How many bonds does nitrogen like to have? 3. And how about chlorine? 1. So let's see if we can make all of those happen. We could make that happen by putting a double bond here. So let's take one of these lone pairs off and make a double bond here. So this oxygen now is 2, 4, 6, 8. It's got 2 bonds. That's going to have a 0 formal charge. But what's not quite right here? The nitrogen has too many, and the chlorine doesn't have enough. But we don't need to make multiple bonds. We just need to move one of these lone pairs. Same number of electrons. Chlorine has 1 bond, an octet. Nitrogen has 3 bonds and an octet. Oxygen has 2 bonds and an octet. There's our Lewis structure. Our central atom is nitrogen. How many electron groups around the nitrogen? 3. There's a single bond, that's 1 group. There's a lone pair, that's 1 group. And there's a double bond, is 1 group. So we've got 3 groups. 3 electron groups. How do 3 balloons arrange themselves? Right? You're going to spread out, be flat. Ooh, that last one's got a hole in it. So we're going to have the nitrogen, and we're going to have oxygen, and we're going to have a lone pair, and chlorine. So what's the electron geometry? Trigonal planar, right? Trigonal planar. That's looking at the electrons. But it's asking us for the molecular geometry. So what we're going to do is we're going to make the lone pair invisible. And so we look at this and we say, well, what did we call that? Bent. So bent is the molecular geometry. It also says predict the bond angle. So that's this angle between these two bonds. Yeah. It'll be less than 120. Yeah. Because we've got this lone pair over here. The lone pair is extra repulsive. If it was all the same things, it would be 120. So this is going to be less than 120 because of the lone pair. We don't need to go into how much less, just less. Any questions? Predict the molecular geometry of I3 minus. Well, 3 iodines, they're going to have to be in a line of some sort, right? We've got 3 iodines. They each have 7 valence electrons, and there's a -1 charge, so we add 1, and so that's 22 electrons. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18,